Okay, today we're going to talk about verifying trigonometric identities. And we're going to learn how to do exactly that. So only one objective for today. Now we've started to do this already with Chapter 4, but we're going to do it a lot more in detail in Chapter 5. So let's talk about some tips and tricks first. So, like we said before, we want to work with only one side of the equation at the time, okay? Pick the most complicated one because it's got more to work with, okay? Look for opportunities to factor an expression, to add fractions, square binomials, or create a monomial denominator. And we want to also look for opportunities to use our fundamental identities that we introduced last chapter and then reintroduced again in the last lesson. So make sure to note which functions are in the final expression that you want. Note that sines and cosines pair up well because of sine squared plus cosine squared equals 1. Secant and tangents pair up because of 1 plus tangent squared equals secant squared. And cosecants and cotangents also pair up as well for those Pythagorean identities. Now, if the above guidelines did not help, try converting terms to sines and cosines, especially with tangents and cotangents, because remember, tangent is sine over cosine, and cotangent is cosine over sine. So always try something. And this is the part of math where we learn how to experiment, because even paths that lead to dead ends can provide insight into the problem. So it's kind of like Edison, you know, he failed 1,000 ways to learn how to build the perfect light bulb. Well, he didn't fail 1,000 times. He learned 1,000 ways that weren't ideal, okay? But even that told him information that was positive. So the only thing to remember is you can't do operations to both sides of the equations. So things will never cross your equal sign, okay? We're going to only do operations to one side of the equation. So no addition property of equality, multiplication properties of equalities, all those properties of equalities we're not going to do. So you're basically limited to multiplying things by different forms of 1 over itself, factoring, and all the other things that we talked about on the last slide. So let's see what this looks like in actual problems. So here's our first identity. We want to verify that cosine of x plus sine of x times tangent of x equals secant of x. Remember, I said we want to start with the most complicated side of the equation because it's got the most to work with. And then you're looking and you're saying sine, tangent, cosine. Well, I know that tangent is sine of x over cosine of x, right? And I'm multiplying that by sine of x and adding cosine of x to that, right? And so secant of x will be over here. And then you're saying, wow, if I do this, then I've got a fraction. Okay, so I end up with basically sine squared x over cosine x. So if I've got a fraction, then I need this cosine to be a fraction as well. So if I multiply this cosine by another cosine of x over cosine of x, remember, this is a form of 1. It's not changing its value. It's just making it have a common denominator, so I can add it to here. So then I end up with cosine squared x over cosine x. So now I have common denominators. I can add them together, and I get cosine squared x plus sine squared x all over cosine x equals secant of x still. I haven't done anything to that other side of the equation. And now we know that sine squared plus cosine squared equals 1. So I'm left with 1 over cosine of x equals secant of x. And 1 over cosine is my definition of secant of x. So now we can see that we have verified that the left-hand side equals the right-hand side. We know that when both sides are equal. So yes, that is a true statement that cosine plus sine times tangent does equal secant. Let's try another one here. And with this one, it's a little bit more difficult to see what is the most complicated side, but I can see that we only have one fraction here and we've got two fractions here. So I'm going to manipulate this second set, okay? And this is going to be a little bit more difficult because I need common denominators in order to subtract these two fractions, which means I'm going to have to multiply this first fraction by the denominator of this second fraction over itself. So another form of 1. So 1 minus tangent of x over 1 minus tangent of x. Okay? So now I've got cosine and distributing this, right? So cosine of x times, oh, not times, sorry, minus tangent of x times cosine of x all over 1 minus tangent of x. So that's just what we've done with this first part here. Now we've got a minus and our second fraction, 1 minus tangent of x, and that will equal just sine x cosine x over sine x minus cosine x. So we see that we have common denominators, so we can combine the numerators, okay? And this gives me cosine x minus tangent cosine x, tangent x cosine x, minus another cosine x, all over 1 minus tangent x, equals our right side, which is sine x cosine x over sine x minus cosine x. And we can see that the cosines are going to cancel out. And then if I remember properly, tangent is sine divided by cosine, right? So I'm left with a negative, oops, I wanted to do that in a different color. Back to black. Negative sine x over cosine x times cosine x over 1, all over 1 minus tangent of x. And my cosines will cancel out. So I just have negative sine x over 1 minus tangent of x equals my sine x cosine x over sine x minus cosine x. Okay, so at this point, we're saying, wow, I'm down to one fraction, but things still aren't looking too good. So what on earth can I do to really figure this out? Because I need a denominator of sine x minus cosine x, and I'm stuck with 1 minus tangent of x. Well, if I think about it, breaking this tangent of x down, I've got 1 minus sine x over cosine x, right? Now, if I could multiply my fraction, this fraction, by something over itself, it would have to be something that made it look like this. I'm going to try multiplying everything by cosine of x, but not just a regular cosine of x, because I need this top thing to be positive. Okay, so I'm going to multiply everything by negative cosine of x over negative cosine of x, which gives me a positive sine x cosine x on top. So now my tops finally match. This is like a Rubik's Cube of math problems. Only there's no algorithm to tell you how to do each problem. Okay? Now, for the bottom, multiplying negative cosine times 1 is a negative cosine of x. And multiplying negative cosine times negative sine over negative cosine gives me a positive sine of x. Well, conveniently, I can rearrange those to show that I have sine x cosine x all over sine x minus cosine x, which equals, yay, my right-hand side of my equation. Okay, that's it. That's it for this problem. Let's work on converting to sines and cosines. We've done a lot of this already, okay, but it helps to do it a little bit more. So if we look at tangent, we know that tangent is sine x over cosine x. We know that cotangent is cosine x over sine x, and that's all over cosine of x, and that should equal secant of x, and we can see these all cancel out on top, so I'm left with 1 over cosine of x equals secant of x. And yes, we've kind of done this last part of it in a different problem, so secant x does equal secant of x, and we're done. Okay, so not all of these are tough. Now we're going to show you a technique where sometimes you have to work with each side separately. Okay, and the key for this is basically leave some room on each side. So my equals are going to go down the middle of my page so that I don't get too confused with what I'm doing. So I'm going to start with working with this left-hand side, okay? Because I can see that I can break this fraction apart because I have two things on top and one on the bottom. So I can break it apart to 1 over sine theta and then a minus sine theta over sine theta, which gives me cosecant theta minus 1, okay? And that's about all I can do to simplify this. Well, now I can look at my other side of my equation. And I see here that I've got cotangent. And remember we said cotangents and cosecants play nicely together. So if I remember that 1 plus cotangent squared equals cosecant squared, then cotangent squared equals cosecant squared minus 1. So I'm going to turn this cotangent squared into a cosecant squared theta minus 1 over 1 plus cosecant theta. So now we're looking at something that has things all in terms of cosecants. Once I look at this and this, so everything's in terms of cosecants, I can probably work with this. Now, looking at this top, we haven't talked about factoring, but I see I have basically what's a difference between two squares. My first term is a square, my second term is a square, and the middle is a square. So this can be factored out into cosecant theta minus 1 times cosecant theta plus 1. That doesn't look good. And that will all be over 1 plus cosecant theta. Okay, so now my 1 plus cosecant thetas cancel out, and I'm just left with cosecant theta minus 1, and that now equals my right-hand side that I worked on earlier, and yay, we're good. Okay, so we showed you a little bit of factoring. We showed you working with each side separately. Notice that at no time did anything cross from side to side, or did I do anything to both sides of my equation. I simplified both sides separately. So we've learned a lot of little different techniques. You might want to watch this video at a very slow pace. You might want to watch it a couple times. And we're going to do lots of practice problems in class. That's it for now.